This is a typical example of a boat cruising up a river at a standard speed. From this alternator at present, we are producing 13.8 amps. Now, if you do a 5-hour journey, that's only going to be about 75 amps charging. However, by simply adding an enhanced charging system, the same alternator is now producing 108 amps. So that is an increase well in excess of 500%. So the question is, are we going to damage anything by charging our batteries 5 times faster, or can this be safely achieved without any fallout? As you can see, we are charging at 14.9 amps, and simply by adding an advanced charging system, we charge at 109.5 amps. Remove the advanced charging system, and we're back to our lower charge rate. This is a standard alternator on a split charge system, and then I'm going to put the advanced charging on. So it really didn't rise that much. Our standard alternator is producing 14 volts at the alternator. However, as with any boat, there's a cabling from the alternator to the split charge system to your battery bank. By the time we get to our batteries, we are only at about 13 volts. You can clearly see by simply raising the voltage by 1 volt or 1.4 volts, the current going into it went from 20 amps to over 100 amps. This is a dramatic improvement and reduces your engine running time. So in reality, how do we actually achieve this? Alternators are fantastic workhorses. They will produce their power at full output all day, every day, without any problem whatsoever. Trouble is, they're not the sharpest tools in the box. They're designed to start your car engine every morning. They're not designed to charge large battery banks. It's purely a matter of intelligence. So they've got the brawn, they haven't got the brains. So how do we get them the brains? Simple answer to that is to override their standard regulator, which is preset at around 14 volts, and give them a much more intelligent regulator. The first thing you can fit, and the lowest cost thing you can fit, is an advanced alternator regulator. This simply overrides the standard alternator's regulator and basically says, stop what you're doing, we will take control, and we will charge the battery based on information gleaned from the battery. Or option 2, at Sterling we've developed a new product called an alternator to battery charger. And this fits down line from the alternator and artificially pulls the alternator's voltage down, but then boosts the voltage coming out of the product itself. This ends up giving you exactly the same results as an advanced regulator without all the difficulty and potential warranty problems associated with such a device. It is, however, approximately 2 to 3 times more expensive. As we saw there, we were charging this battery bank at about 20 amps from the standard alternator through the splitting system to your batteries. We're going to change nothing except replace the split charge diode with an alternator to battery charger. Now let's see the difference. Okay, here we are again, cruising down the river at our standard cruising speed, charging the batteries. The only difference we've done this time is we have replaced the split charge diode with an alternator to battery charger. So let's see the difference. As you can see, we're charging at about 15 amps. I will now activate the alternator to battery charger. This will take a few seconds to go through its warm-up cycle and engage the alternator's power. As we can see there was a 400% improvement simply by fitting the alternator to battery charger. That would increase the fuller the battery gets. At present, this battery is very empty, and therefore you're only seeing a 4 times charge rate. If that battery was fuller, that differential would be much, much higher.